Hey there, everyone, all marketers and marketing analysts. Yesterday, I had posted on LinkedIn a question from a statistic textbook, which is on linear regression, and I believe that any one of you and a lot of you I know that are actually trying their hands at statistical modeling. Because of all the popularity around things like, say, marketing mix modeling and experiments and causal inference and stuff, but it's also important to really understand concepts very well. And in this short, very 7 to 10 minute video, I want to explain linear regression in a way that you might not have been exposed to. So here it is, and again, this is for the uninitiated. If you're already familiar with linear regression, if you think that you're fairly an expert or fairly advanced in it, you may skip this video, but it's for all of the rest of you. So this is the question: which of the following are linear regression models as they are, or if they can be rewritten with the parameter, some parameter being held fixed, and if some transformation is required. So these are the equations. This is, again, like I said, from a textbook called Statistical Modeling by AC Davison, very popular one. And this is from the early on in the textbook, from the linear regression chapter. And these are the equations that have been provided. As you can see, the first one has this intercept, and then you have the coefficients, and then you also have x and x square. So you might be tempted to think that because there's x square here, it's not a linear equation. But the core concept here is that the model is linear when it's linear in the parameters. That's the important thing. And the parameters here are the coefficients, beta, for instance. These are the coefficients for the different variables. And it's not necessarily linear in the predictor x. So that's not important. So this is the general form we all know: y equal to uh, beta 0 plus let me just increase it, beta 0 plus beta 1 into x1, and so on and so forth. So this is the summary output. I'll come back to this later. So this is actually what the question asked for, like for each model, whether or not this can be uh, rewritten, or it is already there in the form of linear regression, and what would be the nature of the response variable. And there was another part of the question, which was the design metrics. It's not as important immediately, but we'll see it's not that difficult either. So you can see that for the first one, it's actually already in the form of linear equation, because what's really happening is that the parameters are all linearly present. There's no power, no products, and they're not in denominators either. And therefore, the design matrix is simply 1 by 1 by x, as you can see, by 1 by x squared. That's how it is. So a linear regression can actually be represented in the form of a matrix. This is probably something, if you are familiar with vector algebra or linear algebra, you will be familiar with these things. But if you're not, then you can skip this part. So the response variable remains y, because you also don't need any transformations. So that, therefore, this is a linear regression model already. So you don't need parameter fixing or transformation. For the second one, though, you'll see that it is no. And the first one, remember, as is, that's what it's replying to. So as is no. It's not in its current form, not a linear regression model. It is not linear because beta is appearing in the denominator. It's actually in the denominator, as you can see. It cannot be rearranged in a linear combination of parameters, but with transformation, with rather not with transformation, but with fixing a variable. Remember, that's what it said, fixing a parameter rather. You can do that. You can fix beta 1, you can set it to c a constant, and then you can define a new variable as such, z, where you're defining it as 1 by 1 plus cx, which is coming from the fact that c is basically a constant, replacing beta 1. And then in that case, your equation becomes y equal to beta plus z, beta into z plus an error. So that becomes linear in beta 0. So that's how you can redefine this. Basically, your response variable remains y, and your design matrix, therefore, takes the form of 1 by 1 plus beta x, or 1 by 1 plus cx. So that's basically your answer for the second one. The third equation is in this form, where you again have all of the parameters in the denominator, and you'll see that it can be done when you are actually carrying out a transformation. You cannot actually uh, just fix one parameter, like make it constant, and still leaves the reciprocal form. You can actually check, if you try to do that, you can just do it manually. If you try to fix one of these things, there's still going to be another parameter that remains in the denominator, and therefore what you have to do is take the reciprocal, where you have to take w is 1 by y, and then you actually have this becomes linear in parameters, right, with the w version of it, and therefore the response variable simply becomes the response 1 by y. Now, if we look at these three questions so far, this is the output that's been described here. So, as is, for the first one remains y. The second one, you have to fix or make the one of the parameters or coefficients constant, and it still is y. And the third one, we saw we have to do the transformation by taking reciprocal. Therefore, the response variable becomes 1 by y. For the next one, we'll actually see that for this one, again, as is doesn't work with beta 2. So basically this is beta 1x to the power beta 2, and therefore if we fix this as a constant, then it takes the form of z equal to x to the power c, and this is linear in beta 0, and um, this is linear in beta 0 and beta 1, essentially. So you have to fix one of these constants, and the design matrix becomes 1, and x to the power c. So that's your answer here. So in this case you will have to fix the one which is in the power. So that's what you will see in the output here. Fix beta 2, but the response variable remains in the same format as given, like y. So the last one is basically not possible at all, given the kind of approaches that have been suggested. So this one is beta 1 x1 to the power beta 2, beta 3 x1 to the power beta 4. So both of these are in the powers, and since both of them appear as exponents, this becomes non-linear in these parameters, and with a single parameter fix it's actually not possible at all, because it still remains, even if you fix one of these, it remains non-linear in the other parameter with respect to the other parameter. So we need to fix both, and that option is actually not there in the question. If you read the question, if when a single parameter is fixed. So I'm just rushing through it because I wanted to give you a quick understanding. You can see this video, you can just pause it and take your time. You're going to have to give that amount of time anyway, but this document itself is very self-explanatory as well. And then if the question allows multiple parameters, fixing multiple parameters, then if you fix both of these beta 2 and beta 4 as given in this equation, then yes, it would work. In that case, it would define z1 and z2 like this, and then you will actually have a linear form of the response variable y, which is given in terms of beta 0, beta 1, beta 3. So that's then then the design matrix in that case would take this form, 1 x to the power c, and again another x to the power c. But yeah, no transformation will actually help linearize these models. Again, if you can think of a transformation, do let me know. But I'm not aware of any, or maybe I can think of it, but it doesn't seem like it's possible, and certainly cannot do it with just one parameter fixed or as is. So like I promised, this is a very short video. As you can see, it's already it's still not yet 9 minutes, but I wanted to keep it short. I want to give a very quick introduction to people who are working with marketing and also with data, working in marketing but with data, and trying to get into marketing analytics, or sort of doing both. For them, I think they have to try their hands a little bit from time to time with statistics and with statistical modeling. I do think that regression is very important, and the very concept of linear regression is often misunderstood because of the word linear. Because people, at the very first example, people think that it's in the variable, the power of the variable, but it's not. It's actually the power of the it's actually the linearity in terms of parameters. So that's what's more important. There are obviously many other aspects to it. This of course cannot obviously be exhaustive in just under 10 minutes, as you understand. But hopefully this was useful. Do let me know in the comments if you want this document. I'll share it with you. And yeah, keep following me for more content on marketing analytics and insights. Thank you.